Okay, when you're looking here, we are going to be looking at, let's use blue today, why not? Factoring out the greatest common factor. All right, so it's taking out what they have in common. We're going to do grouping. We're going to work on trinomials, difference of squares, perfect square trinomials. So all of these are different types. Some of them are very similar. The sum or difference of two cubes. This one here, very few remember, but you have seen it. The strategy for factoring, so what do you use when out of these here four? And factor algebraic expressions containing fractional and negative exponents. So what do you do when it looks weird? So let's start with the very first one. Let's just see what you remember. Try the first two, pause it, let's see what you get. Okay, when you looked at this one here, you should have looked at the 10 and the 4, and you should have seen there was a 2 in common, the x cubed and the x squared. So the smallest factor, or the smallest exponent they have is x squared, so we can take out an x squared. So when we divide the 10x cubed, because that's what you're technically doing, by 2x squared, we get 5x. And when you divide the 4x squared by 2x squared, you get 2. So that is your final answer right here. Okay, the next one was a little tricky. I wanted you to recognize that there's two terms here, and both terms have an x minus 7 in common. So what you're factoring out is an entire term or entire set of parentheses. Once you take out the x minus 7 or divide by it, that will leave you 3x on this side. You divide by the x minus 7 here, and you are left with 8. Okay, now let's go through. I have put the reasonings beside these steps. You do not have to do that. I'm just helping you so you understand what those laws were that we used before. Our first thing we're going to do is regroup these. I'm going to put the first two and the second two together. Because when you look at these four terms, they don't all four have anything in common, especially since this is a 1. So there's nothing I can take out. There's four terms, so the only method we have of four terms is grouping. So we put the first two together, which is why they're in parentheses, and the second two. Now I've effectively made two small problems. So I'm going to use distribution or factoring, and I'm going to take out the greatest common factor between 3x cubed and 3x squared, which is 3x squared. Don't forget your 1. Well, the greatest common factor of 2x plus 1 is just 1. So you can either leave this or put the 1 in front. It doesn't matter. Sometimes the 1 helps us not make mistakes. Out of these two, you now have a 2x plus 1. We're going to factor him out, leaving us with 3x squared plus 1. Don't forget these plus 1s. And that's done. Now, if there was an equal to 0 back here, I would have to finish this problem, and that's what this is. We'd have to set each factor equal to 0 and solve. So we'd subtract the 1, divide by the 2, and that'd be the first one. And if we set this one equal to 0, we subtract the 1, but then we're taking the square root of a negative, and that's imaginary, which we will learn later. Right now, we're going to say that's not possible yet. It will happen. All right, pause and try yours. What I wanted to see is how you dealt with this negative in the middle. So nothing in common, so we can't do that. So we put the first two together, but technically this is really plus a negative 10x. So we put those two together. The first two have an x squared in common, leaving us with 5x plus 4. My second set of parentheses has a negative 2 in common, leaving us also with 5x plus 4. When we look here, our factors are the same, so we can factor them out. 5x plus 4, leaving us with x squared minus 2 in the second set. This is not a difference of squares, so we are finished. There is no equal sign, so we do not have to continue. All right, factoring trinomials. When you look at this here, if there is a 1 in front, this is the one you should remember easily. You don't have any work to do. You look at the last and you try to get the middle. So it's factors of the last that add or subtract, whatever it may be, to the middle term. So here I'm looking at factors of 6 that add to 7. Well, the factors of 6 that add to 7 are 6 and 1. So this is x plus 6, x plus 1, and you could have written that in any order you wanted. When you factor it out, you would have had the x squared. When you did your x squared, 1x plus 6x is 7x, and 6 times 1 is 6. All right, try the other three. Okay, you should have recognized that the factors of 9 that give you 6 are 3, but to get a negative 6, I must have a negative 3. So it's x minus 3, and they're actually the same. So I'd really like you to write that x minus 3 squared. You can write it the other way, but this here will help us later on. Factors of 15 that subtract to 2. Well, I know it's 5 and 3, but which one's positive and which one's negative? Well, if I need a positive 2, it's going to be a plus 5 and a minus 3 because that equals a positive 2. So that's how I put them in my thing, x plus 5 and x minus 3. Next, same thing, but now this is a negative. So all I have to do now is make the 5 the negative and the 3 the positive to get to my negative 2. So this is x minus 5 and x plus 3, and you're done. Now, that's only when there's a 1 in front. When there's not a 1 in front, we have to do a little bit more work. All right, and I made this one ugly on purpose so that you realize that this is something you should be doing. Step 1 is this is not in the right order, so we have to write it in the right order. So it's minus 3x squared plus 10x plus 8. Next step, I want this to be positive. It just makes my life a little easier. So I'm going to take out a negative 1, but I have to take it out from everybody. So that's 3x squared minus 10x minus 8. Next step is there anything else I can take out? Do they have anything else in common? The answer is no. So this guy, I have nothing to do. Now we have to factor, but I can't look at factors of 8 that add to 10 because I have a 3 here. So we're going to do this by grouping your 4 method that we just learned before. We're going to cheat. So we're going to take 3 times negative 8, which is a negative 24x squared. Now I need factors of 24, and since it's negative, subtract to 10. I know that that is 2 and 12. So I need a 2x and a 12x. But if I use 2 and 12, that gives me a positive 24x squared when I multiply these, and I need a negative. Well, here I need a negative 10, which means the larger one is negative, giving me the negative 12. So when I add them, that equals my negative 10x. When I multiply them, that equals my negative 24x squared. Now, what I'm going to do is take out the negative 10x and replace it with 2x minus 12x because that's the same thing. I'm going to drop down my 3x squared. I'm going to leave the 2x minus 12x because that equals my 10x, and I'm going to drop down that negative 8. Now, it's like we just did. You have 4 terms, so I need to group them. So I can put the first 2 together. Remember that positive has to go with, become plus a negative, so that 12 has the right sign. These 2 have an x in common, giving me 3x plus 2. These 2 have a negative 4 in common, giving me a 3x plus 2. This term and this term have a 3x plus 2 in common, so I can factor him out, leaving me with an x minus 4 in my second set of parentheses. Now, if there were an equal sign here, equal to 0, I would set both factors equal to 0 and solve. And this time they both work, so I'd have 2 solution sets, or 2 times that this thing crosses the x-axis. Your turn. Try it. Give it a shot. So you're pausing the video right now. Okay, your first step is, do they have anything in common? And I'm kind of hoping you saw they had a 7. So if we take this and we factor out a 7, right? So this gives me 2x squared minus 5 plus 2. That's a lot easier than dealing with this. You would get to the same answer, it's just a lot harder. So now I'm looking factors of 2. Oops, I forgot my x. Factors of 2 that give you 5 is not possible, but we can't forget about this too. So now we need to make 4 terms. Oh, I forgot on the other page. Hang on, let's back up just a second. All right, I forgot because I knew it wasn't important, but you do not. This negative 1 cannot disappear. Technically, he is down here and he's here with your answer. But since he does not have a variable, he is not a solution. So when I set it equal to 0, I do not have to worry about him. But I do have to worry about it if I don't have it set equal to 0. So don't forget him. So we're going to not forget this guy, but he is important. So this is 4x squared, factors of 4 that add to 5. Well, that's pretty easy, 1 and 4. So a 1x and a 4x. but I need a -5. Well, to get a negative and still retain a +4, they both have to be negative, because a negative times a negative gives me my positive. Add them together for my negative. Drop down my first term. Drop down my last term. Oops, I just wrote a 4 instead of a 2. What's going on here today? Okay, drop down my last term. We have to group. Remember, make this plus a negative here. So we put the first two together, the last two together. This guy has an x, so that gives me 2x minus 1. This guy has a -2, which also gives me 2x minus 1. The 2x minus 1 is what is in common, leaving me with x minus 2. And I can't forget my 7 that I had out front. That's my final answer if there's no equal to 0. Equal to 0, set them equal to 0, and your answers would have been 2 and 1/2. All right, difference of squares. Let's see if you remember. Pause and try it. You should have remembered the difference of squares is the first square root of the first plus the square root of the last times the square root of the first minus the square root of the last. All right, if you wrote this and you switched that plus and minus, nobody cares. I'm hoping right here that you tried to put 2x plus 5 and then checked it. And you should have got that that's never works because it's prime, because it's addition. There's no such thing as a sum of squares. That can be factored anyway, not yet. Okay, perfect square trinomial. So this is a little bit, it cheats so we don't have to do so much work if it works. Like this one's not hard, but if you recognize that this is a perfect square, it's x. This is a perfect square, it's 8. This right here means we multiply those squares together, square roots together, and double it. That's what the 2 is. That equals my middle term. It's a perfect square. So multiply these two, we get 8x. If I take that times 2, does that equal my middle term? The answer is yes, it's 16. So now all we have to write is x, this sign, whatever it may be, minus 8 quantity squared. Okay, try yours. All right, so you should have said this is 6x and this is 4. Multiply together, 24x, but when I double that, it does not equal this. So this is not a perfect square trinomial. You'd have to do that the long way. It's not possible, but that's what would happen. All right, cubes. These are always fun. You have two formulas you basically just have to memorize. You take the cube root of the first, cube root of the second, and the sign. That's what goes here. Now you square the first, alternate the sign, multiply them together, square the last. And that's what you get for a perfect cube. Here, let's give you an example. We have 125x cubed. Well, the cube root of 125x cubed is 5x. We have 8, and the cube root of 8 is 2. Same sign, minus. So now to get to the next answer, I take 5x squared, alternate the sign. So if this is negative, this is positive. If this is positive, this is negative. Multiply the two together, your 10x, square the last, which is your 4. And that's your answer. All right, pause and try yours. So 64x cubed, that's actually 4x. 27 is 3. So to write this out, we go 4x plus 3 times 4x. We have to square this now. So that's 16x squared. Alternate the sign. Since he's positive, this is negative. Multiply them together. 12x plus the last term squared, which would give you 9. I hope you did well. You have to look at the formula a couple times in order to get that down, but it works. All right, this is just a review. Your first step always is take out a greatest common factor. Second step, look at what you have. If you have two terms, it's one of two things for us. It's a difference of squares, that means it has to be subtraction, or they're perfect cubes. It's not one of those two, it's prime. 3 terms. We're kind of hoping it's a perfect square trinomial so we don't have to work. If it is not, you have to group using 4 terms. There is a method called trial and error. I do not like it. It usually gets you into trouble. 4 terms is always grouping. It's your only option. When you are done, you have to check your factors to make sure nothing can factor out. All right, let's continue. Last but not least, negative exponents, or even just fractional exponents. I combine them into one thing here. You have 2 terms because there's one addition sign right here. So this is multiplication and this is multiplication. You're looking at what they have in common, just as if this was x minus 1 and x minus 1 without a negative 1/2. Well, since x minus 1 to the negative half is what they have in common, I can factor him out. All right? All right, so if I'm taking out, or actually dividing is what you're doing. This is going to cancel, this is going to cancel, and in my parentheses, I'm going to have an x plus 1. Don't forget that cancels to 1, not 0. And you're done. So give those a shot. Let's see how you do. And remember, you always take out the smallest. Okay, good luck on your homework. I hope you do well. Have a great day.